Is my screen visible, Divya?
Yes, sir.
Okay, yeah, thank you. So good morning, all of you. We have started the filtration process in the last class, okay, and the layout or the treatment chain. Now we are here, okay. Immediately after the sedimentation process, you have to now separate the flocks, okay, which is escaping from a sedimentation option or treatment that you can have the filter or filtration systems, okay, both the cases of surface water and also groundwater, and the filtration is the one of the polishing step, okay. And filtration is very simple. That's the unit operation of separating solids from fluids. That's what we have discussed. Okay, it is also being called as a polishing step to remove all the flaws. That is in the case of surface water treatment, or in the case of groundwater, we may add some chemical to remove hardness. Then it is possible to remove the precipitant particles, which is not removed in the settling process also. Okay, in the case of surface water, and you can call it as simple flocks. In the case of groundwater treatment, you may add chemicals. In that sense, you can simply remember in terms of precipitant particles. Precipitant particles. Okay, yeah. These are the different classifications we have discussed in the last class. One is about granular filter, another is about free coat filter. So granular meant for different stratified layers of sand in a sequential order, and pre-coat filtration or filters are, you can use diatomaceous earth or diatoms, okay, and gravity by simple gravity action, and you can either have pressure or vacuum in the sense of pressure filters. Depending upon the rate of flow, you can have or rate of filtration, you can have slow sand filter and rapid sand filter, and depending upon the operational mode, you can have depth filtration and cake filtration. Depth filtration is removal mechanisms may happen throughout the entire depth of filter bed, and cake filtrations, removal mechanisms may happen only at the top. The example of depth filtration, you can remember rapid sand filter, and the example of cake filtration, you can remember slow sand filter. Okay, in the case of depth filtration or rapid sand filter, during the course of time, the efficiency of the filter will come down because of blockages. Then you have to backwash the filter. But in the case of cake filtration, backwashing is not necessary. Stop the filter, you remove the top layer and refill with the new material. That's a different classification of filters based on different conditions. Okay, that's what we discussed. Gravity by simple gravity, and the pressure and vacuum filters are rely on applying some mechanical means to create a pressure differential to force the water through a filter. Okay, so simple gravity, and here it is here to create a pressure to force the water through the filter. Okay, and these are gravity filters. Now we could understand better. Different layers of sand is being arranged. You can allow the water to pass in, and water will be collected through a central manifold system and also laterals. Okay, and if it is anything on the blockages here and there, okay, and the efficiency of the filter will come down, and you just now reverse the flow, or otherwise you can go for a simple backwashing. Okay, backwash water can be collected through this trough, wash water troughs, and taken further for treatment options. That's what we discussed. Okay, so this is now in a clear systematic diagram, like the graded gravel, and these are laterals, these are central manifold pipe. Okay, these are wash water troughs, this is your filter tank. So these are the physical components in. Okay, pressure filters will look like, because anyway by the way of mechanical means, you have to either apply pressure or you have to apply some sort of a vacuum. So thereby these water will be forced through the filter, and treated water can be collected in the outlet. Okay, and filtration medium, you can either use perforated plates or woven material or granular materials such as sand. So predominantly these granular materials such as sand is used for filtration operations. Okay, and if it is the perforated plate, you can say perforated plate filters. If it is being used with woven material, that is woven septum filters. And if you are using granular sand, you can simply call it as granular filters. Okay, and depending upon the different media, you can also classify into dual and also triple media. Dual media, it is anthracite plus silica sand, and triple media, it is anthracite, silica sand, and garnet sand. So this is what we discussed in the last class. Okay. So filtration sand, monomedia filter, filtration coal as well as sand, dual media filter, and sand, coal, and also garnet. This is about the dual mixed media or triple media filter, and the bottom gravel layer act as a bottom layer or to support these sand layers. Okay, and depending upon the operation, you can have slow sand filter and also rapid sand filter. Slow sand filters normally operate in the range of 1 to 10 metric per day per meter square of your filter area. In the case of rapid sand filter, it will go up to 100 to 200 metric per day per meter square of filter area. Okay, so yeah, this is the slow sand filter. That's I told you. Like the different parts or components of the filters are: number one is containment. Okay, and number two is your under drain system. Under drain system, and top you have a wash water truss. Okay, slow sand filter and rapid sand filter. These also again gravel media or media, different layers of sand. That is a filter bed. This containment structure, and bottom you have under drains, and top you have wash water troughs to collect the backwash effluent. Okay, and depending upon the operation, you can have depth media filtration, and also cake filtration. It's very simple. Depth filtration, the removal mechanisms of these solids or flocks may happen throughout the entire depth of the filter bed. Okay, and these flock materials may clog the interstices or space in between the soil grains. Thereby, the efficiency of the filter will come down. In the case of depth filtration, you may need backwashing. That's what we discussed. In the case of cake filtration, the removal mechanisms may happen only at the top. Okay, and if the filter is getting clogged, what you just remove or scrap out this material and fill with the new one. Okay, so in this case, backwashing is not necessary. The example of depth filtration here, rapid sand filter. Here the example is about slow sand filter. Here is backwashing is necessary. Here is backwashing is not necessary. Okay, so please remember these two concepts. That's what we have discussed. Okay, and these are the transport mechanism. How the removal mechanism may happen inside the filter bed. Number one is straining. Number two is about sedimentation. Number three is about inertial and centrifugal forces. Okay, so imagine now the top layer of the sand will act as a micro strains. Okay, top layer of the sand will act as a micro strains, and the particles which are bigger in size will be trapped onto a surface. Okay, this is very simple. You can call it as straining or micro screening technique. Okay, top layer of the sand will act as a micro strain, which will not allow the bigger particles or bigger flocks to migrate further into a sand bed. Okay, the first concept. Second concept is sedimentation. The interstices, the space in between the two individual grains, 1, 2, okay, will act as a sedimentation basin where the particles can settle down without any difficulty. Okay, this is a second mechanism. Third mechanism is about inertial force. Okay, sieving or straining, we have discussed in the last class. Okay, that top layer of the sand layer will act as a micro strain, which will not allow the bigger particle to penetrate further. Okay, then the sedimentation is that the particles. Okay, so two individual grains, the space between the individual grains will act as a sedimentation basin where the particles start settling down. Okay, so that you claim to be like sedimentation action. Inertial forces, that inertial and also centrifugal force act upon the particle with the specific gravity higher than that of the surrounding water, causing them to leave the flow lines and come in contact with the sand grains. Thereby, the separation mechanisms may happen. Okay, so this is what the three predominant mechanisms which may happen in the filtration beds or filtration techniques. Okay, so this is what we have discussed. Micro straining. Now could understand better. These yellow color are flocks. Okay, yellow color are flocks, and the size of the flock is bigger than the size of the opening. Thereby, it will trap onto a surface. Okay, there could be possibilities of adsorption also. Okay, and this third one is about your centrifugal and also inertial forces. Okay, yeah, these are the filter components we have discussed. Number one is your filter box, usually constructed in reinforcement concrete or otherwise is corrosion resistant steel. Okay, so you have to be very cautious to design the filter box because it has to withstand water pressure, water column pressure, as well as your self weight of your sand or the filter bed, as well as your under drain system. That's something is important. Okay, yes. So additionally, that the structure must watertight and at pressure corresponding to weight of the maximum water column expected. That's what. So please make a note on filter box has to be designed for that it must be very strong enough to retain all your filter bed and water column as well as your under drain structure. Okay. Usually this filter box can be designed as either square or rectangular in shape, and if it is more than two, that is called as filter galleries. Please make a note on. And you can have a minimum of two, okay, minimum, or you can provide multiples of two. That provides the economy of common walls and minimize the piping. That also we discussed. And number of these filter units are called as filter galleries. Under system, the purpose is to collect the treated water at the same time to disperse the backwash water at the time of backwashing. Okay, please make a note down. This under systems consist of a central pipe called manifold, and the small pipes on both the sides are called as laterals. Okay, so central pipe is called as manifold, and the small pipes which is emanating from a central manifold pipe, that is called as laterals. Okay, this is something is important. Okay, these laterals also, and these central manifold pipe and also laterals has to be designed very carefully to withstand pressure of water during the backwashing. Okay, that is also something is important, where you can use a maximum factor as 2 times. Hydraulically under drain system must be designed to handle backwash flow rate usually exceed filtering rate by at least a factor of 2. Okay, yeah, this is what I mentioned. So this is your containment structure, and these are central manifold pipe, and this is your lateral. Okay, in actual situations, this central manifold pipe and also laterals are placed under the say example your filter layers like this. Okay, so this is what we have discussed in the last class. And filter media, anyway, that so many filter medias are used, predominantly granular medium, and they may use anthracite, coke, or gravel sand. Okay, in the place of silica or in combination of with silica sand. Okay, these properties are very important. Number one, size of the material, and also size distribution and density of the material. Okay, so predominantly they may use the silica sand, anthracite coal, filter gravel, carbonate sand, and also green sand for different layers. Okay, yeah. And the media selection is very important. If you select a material or media with a smaller size, okay, one advantage is it will increase your efficiency. At the same time, it may go for a blocking, or it may go for clogging very often. So you have to go for a frequent backwashing. Okay, and at the same time, if I go with a bigger material, it will increase your filtration rate. At the same time, you have to also compromise on your water quality. Okay, so please make a note on these 2 points: smaller material and also bigger material. That is being explained in this slides. That's also we discussed in the last class. Okay, and what you have to now define what is filtration rate and what is backwash rate. And filtration rate is calculated by dividing the flow rate by filter media. Flow rate by media of the flow rate by media area of the filter. Okay, this is also again a velocity, or you can simply remember filtration rate is equal to flow, okay, Q divided by area. And backwash also we have discussed. Okay, backwash, that what we have discussed in the last class. Okay, so example, during backwashing, what will happen? You allow the pressurized water to flow from bottom to top, so thereby the bed will be expanded. Okay, bed will be expanded, water level also will rise. So now you just calculate this much amount of water level rise. That's what is being mentioned. Rise rate of backwash water in the filter bay before the water spills into a backwash trough. Okay, so based on that you can calculate backwash rate, which is equal to this flow, that is Q divided by area of your filter. So we make a difference on what is filtration rate and what is backwash rate. Okay, and normally manual operations of like filter operation and also cleaning is very difficult. Normally it is being controlled by simple automated system, either with hydraulic means or by electronic means. Please make a note on. So manual operations is somewhat difficult to either open or close the valves of either inlet or outlet, or say example your backwash the valve system is very difficult. So it is being connected automatically. It will sense automatically. Then either you can use hydraulic means or electronic means to control the total filter system, Okay, yeah. Okay. Filters normally can be operated with either downflow mode or upflow mode. Okay, so please remember two different modes of operations. One is upflow, or sometimes you may use downflow operation also. Okay, yeah. And there could be another concepts called head loss. Okay, please make a note on. And during the course of time, during the course of filter operations, and the particles are getting something is removed or blocked, or say example trapped onto a surface of the say example filter material, thereby the efficiency of the filter will come down. Okay, so the clogging results in a gradual increase in head loss if the flow rate is to be sustained. The total head loss may approach to a maximum head loss provided in the plant, sometimes called as available head loss. Please make a note on. You can allow the like filter to go with the maximum of allowable or available head loss, and after that you have to backwash the filter. Okay, and the operating time between the backwashes is called as filter cycle or filter run. This also we have discussed in the last class. Okay, so the operating cycle between the backwashes, backwash 1 and also backwash 2, it is called as filter cycle or filter run. The head loss at the end of the filter run is called as terminal head loss. Okay, so please make a note on what is filter cycle or filter run, and what is this available head loss, and what is terminal head loss. Okay, yeah. And so I guess up to this we have discussed in the last class, and we'll move on further. And the how to identify whether the filter requires a backwash or not. Okay, it's based on certain indicated criteria. The first criteria is the head loss across the filter increases to a available limit or to a lower established limit, that usually 2.4 to 3 meter of water. Please make a note on the first point. Okay, if it is reaches to a maximum head loss, stop the filter, just go for a backwashing, or you just monitor the water quality of treated water, okay, at the effluent, or at you just collect the effluent or filtered water and check for turbidity, and if it is anything on deterioration of water quality, then you can say the filter has come down the efficiency, or it has to go for say example cleaning or backwashing. Okay, or sometimes is you can have a fixed days. Okay, once in 3 days or once in 4 days you can go for simple backwashing. Okay, so please make a note on. Number 1 is based on the head loss. Number 1 by monitoring or tracking the water quality, and third one is about usually maximum time, once in 3 days or 4 days. Is it okay? Is it fine?
Yes, sir. Yes, sir.
Yeah, backwash. Yeah. So these operations I've already mentioned. It can be either down mode or you can have up mode. Predominantly in the water supply system, they may use downflow operation. Okay, downflow operations. Okay. Yes. Yeah. Now, how the typical operation of the filter will look like. Okay. So please note down, make a note on that. Now the valves A, okay, and valves B and C, D, E. Okay, so these are the valve positions. Okay, so these are the typical gravity flow filter. Okay, remember that you can provide 600 millimeter as a freeboard, and say 0.6 to 0.76 meter as a sand layer, and 0.4 to 0.6 meter as a say example the support layer, that is this gravel layer, and bottom you could able to see the underdrain systems. Okay, yes. Now how to operate the filter and how to clean the filter and how to collect the water as effluent, that you have to see. So these are valves. Okay, valve A here and valve B here, that is effluent, and valve C, that is about here, and valve D, this is about here, and valve E, this is here. Is it okay? So now you just look into the diagram very carefully. Okay, now you have to operate the filter. How the operation of the filter is, now let me make a tick mark. Okay, open the valve A. Okay, open the valve A. Just look into the diagram. Open the valve A. Thereby you can allow the influent to pass in. Okay, so water will be filled, and it will also migrate through the filter. Okay, wall A is on, and wall B is also on. Thereby, the treated water can be collected. Treated water can be collected, and during the operation, all other valves are closed. Is it okay? Able to follow? Open the valve A, allow the water to flow through the filter. At the same time, allow the valve B also in open position. That way, I can collect the effluent. Is it okay? All other valves are completely being closed position. Is it fine? Divya?
Yes, sir.
Yeah. Okay. Then the second one is about the backwashing. Okay, how to do a backwashing. Okay, now what do you have to do? During backwashing, you have to close the wall and A and B. Okay, so A should be closed because I have to stop the influent, and I have to also stop the effluent as well. Okay, so now what I have to do? And open the wall C and D. Open the wall C and D. Okay, C in the sense is now I have to open this wall. Okay, D wall. Thereby, a pressurized water can be say example allowed to pass through this, and water level will rise, bed also will expand. I may collect the say example water, that is backwash water, by simply opening the wall C. Is it okay?
Yes, sir.
This is operation, this side is operation, this side is on cleaning. Is it fine? So you can understand this one. Okay, this is flow operation, and also how the cleaning mechanisms may happen by operating these A, B, C, D, E valves. Okay, yes. Now how to filter to waste. How to filter to waste. Okay, imagine immediately after the immediately after the cleaning. Okay, if I allow the influent to pass in, allow the influent to pass in, what will happen? There could be a possibilities of muddy water, because all other walls are closed. Okay, what I do, I will open only the influent A, allow after backwashing, allow the water to pass in. So I make it only turbid water instead of opening the effluent. This point B, close the effluent for some time, and open the wall E. Okay, that means is you have to purposely waste all, say example, muddy water immediately after the backwashing. Is it okay? So three operations, please remember: during operation and during cleaning and immediately after the cleaning. Okay, if you allow the influent to pass in, and initially because of bed dislocation, and also like you are settled, say example, flocks, and there could be a say example turbid water that you need not allow to go along with the effluent. You just stop the effluent, or close the effluent wall, allow some water purposely to waste. Okay, thereby, and you just monitor the turbidity level. If it is just clear, then you just close the valve E and allow the valve B, and just collect the effluent through the valves. Is it okay? So please remember how to operate the filter by the operation of valves, and how to clean or backwash the filter by opening these valves. And what is the last one is about how to how to filter to waste. How to filter to waste. That's what I told you immediately. The effluent is sometimes filtered to waste for a few minutes after the filter has been washed to condition the filter before it is put in use. Okay, please make a note on after backwashing, and there could be a possibilities of the water with lot of turbidity and just waste purposely. Then you observe the water quality conditions, and if it is reached to a normal level, and close the valve E and open the valve B to collect the treated water or treated effluent. Is it okay?
Yes, sir.
Yeah. Last one is about how to calculate the head loss. Head loss for a fixed bed flow. Okay. So that is being used by Hosini equation. Please make a note of the head loss that occurs when the clean water through flows through a clean filter medium can be calculated using well-known equations. The flow through a clean filter of ordinary grain size, which is ranges from 0.5 mm to 1 mm, or ordinary filtration velocity, that is 4.9 to 12.2 meter per hour, would be in the laminar flow conditions. That is depicted by Hosini equation. That is a dimensionally homogeneous material. Please make a note on the two assumptions to use this Hosini equation to calculate the head loss. Number one is laminar flow. Number two is your material is homogeneous. Okay, homogeneous. Please make a note on these 2 points. If it is laminar flow, and if it is been packed with the homogeneous material, you can use these Hosini equations to calculate the head loss equation. Okay, so this is your Hosini equation. HF, let me write HF is equal to F dash L into 1 minus E Vs square divided by E cube G into V into dP, where F dash is equal to the factor, and HF is equal to head loss, and L is equal to depth of the filter, E is equal to porosity, and Vs is equal to filtering velocity, and G is equal to acceleration due to gravity, and dP is your diameter of the particle. So by using this equation, you can able to calculate head loss of a particular filter bed. Okay, yeah. The F dash is equal to the friction factor related to again coefficient of drag around the particle. Okay, and in the usual range of filter velocity, that is this normally is the laminar flow condition. So F dash, you can use this formula. F dash is equal to 150 1 minus E divided by RE plus 1.75. You can use this formula. Again, RE is equal to, we are already familiar, RE is equal to Reynolds number, VD by nu, velocity into diameter by nu, and VD is also again VD, or otherwise you can simply remember R is equal to VD by nu is replaced by mu by rho. So that's what the equation is being written like this. Okay, so you can also use shape factor because that particles are not spherical. So you can use pi as a shape factor. Thereby RE becomes R is equal to rho V Vs into D divided by dynamic viscosity into pi value. Is it okay?
Yes, sir.
Yeah. Okay. So now these are some specifications of rapid sand filter. Okay, rapid sand filter utilizes a bed of silica sand ranging from 0.6 to 0.75 meter in depth, and the size of the material what you use is 0.35 to 1 mm or even larger, with the effective size ranges of 0.45 to 0.5 mm. The uniformity coefficient of the soil or the silica sand what you are using is about 1.65, and common filtration rate ranges from 2.5 to 5 meter per hour. An important feature of this rapid sand filter is you have to clean periodically by hydraulic backwashing, resulting stratification of the media. So these are some of the specifications you have to remember, and you should also have the enclosure tank and the filter media and also base material. So at least you can remember these some numeric values. Base material, whatever you are using is gravel, maybe is 40 to 60 mm thick, and 4 layers of gravel can have almost 15 centimeter each, and these also the size ranges 2 to 6 mm, 6 to 12 mm, 12 to 20 mm, and 20 to 50 mm. And filter media, you may use 60 to 90, 2 feet to 3 feet in thick. Effective size ranges from 0.35 to 0.6 mm, and uniformity coefficient you can select in the range of 1.37 to 1.7 for your filter beds. Okay, and some of the specifications with respect to the snow sand filter, that is effective size is 0.2 mm, and your filtration rate. Okay, the resulting head loss produced very low flow rate in the range of 0.12 to 0.32 meter per hour, necessitating for the construction of very large filters. So please make a note on at least some. So cleaning, normally I told you backwashing is not necessary. Cleaning was accomplished periodically, draining the filter and mechanically removing the top portions of sand along with the accumulated solid and also biological matter. So please make a note on rapid sand filter. You may require backwashing continuously, very frequently. But in the case of slow sand filter, and backwashing is not necessary because it follows a cake filtration technique. The solid particles or the flock materials which are blocked only at the top. So the only possible way is drying the filter, and you just mechanically remove the top few centimeters of the sand along with the accumulated solid and biological matte. Okay. These are some of the specifications. Filtration media, it is in the range of filter media sand layer 90 to 110 centimeter thick. Effective size ranges from 0.25 to 0.35 millimeter, and uniformity coefficient is 3 to 5. In base material, you can use 4 layers: 3 to 6 mm one layer, 6 to 20 mm one layer, 20 to 40 mm one layer, 40 to 60 mm from the top. Okay, from the top. So this is about the slow sand filter specifications. Okay, you can also have a dual media filter. Anyway, this we already discussed. One is about silica sand, another is about your anthracite coal. Okay, silica sand and anthracite coal as medium. Okay, and you can also have a mixed media, 3 or 4 materials together. Normally, they may use 0.7 meter, 0.75 meter bed with anthracite coal, silica sand, and gravel. So please make a note on 60, 30, 10. 60 is to 30 is to 10 percentage of 60 is anthracite, 30 is about your silica sand, and 10% may be your gravel sand with the varying specific gravity of 1.6 here, 1.6 and 2.6 and 4.2 respectively. So please make a note of. You can also use mixed media filters also. Okay. Yeah. So the last part is about some problems in operation of your filters. Okay. The operational troubles. And number one is formation of mud balls. Another one is about cracking. It's very common. So one we can see with the rapid sand filter. Another is one with the slow sand filter. Okay. Or one with the example of say example depth filtration and what will happen. And in the case of cake filtration, what is the difficulty? Okay. Formation of mud balls is one number of. Okay. So what will happen? Mud from the atmosphere usually accumulates in the sand surface so as to form a dense mat at the top. Okay, number one, please make a note of. So because it is open to atmosphere, some cases. Okay, some cases these all filter galleries are same. Sometimes maybe in-housed. So you may have a filtration galleries or inside the buildings as well. So predominantly most of the cases the filtration or filter galleries are outside, open to say example atmosphere, or sometimes with the open to sky or something. Okay, so thereby because of the heavy wind there could be a possibilities of mud from the atmosphere usually accumulates in the sand surface so as to form a dense mat. Okay, and if you are not doing a proper backwashing, so what will happen, this mud may sink down into the bed. Okay, second point, please make a note on, if your cleaning is not very proper and this mud sink down into the filter bed or sand bed, and this mud then sticks to the sand beds and arrests the impurities, thereby forming a mud ball. Okay, please make a note of. And imagine now this the mud particles are in intermediate of your filter depth, so which will sometimes is from moving from top to bottom, and it will also roll down by because of your water velocity. It may form a ball. Okay, and these mud balls slowly and steadily go on increasing in size and also weight. Okay, during the drown travel, there could be a formulation of bigger or larger size and weight mud balls. Size and weight mud balls. And what will happen? They also then sink down into the gravel bed directly to the bottom, thus interfering with the upward movement of wash water during cleaning. So please make a note on, all your filters are open, and because of the atmospheric mud, it may also say example form a dense mat at the top of your filter bed. During inadequate filter washing, these mud balls may sink down by down, okay, layer by layer, and during the downward movement, okay, because of the velocity of the water, there could be a formation of mud balls. And mud balls again sometimes is slowly and steadily go on increasing the size and also weight, and finally it may accumulate at the bottom of your gravel bed. And this mud ball sometimes may create a lot of problems on backwashing. Okay, yeah, this causes sometimes turbulence around them and thus hinder with the uniform application of wash water. Okay, imagine now at the bottom of the sand grain layer, and mud balls are packed like this. So what will happen? This area it is completely been affected, and this area maybe is open, and whatever you apply with the pressurized water, this portion is completely been blocked, and there could be a uh, 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 only this opening alone the water can penetrate, and thereby the water will come out with lot of pressure. Okay, this causes turbulence around them, and thus hinder the uniform application of wash water, and the high velocities created along the edge of these balls also displace gravel. That's something important. There could be possibilities of even sometimes bed dislocation as well. Okay, the formation of displacement of gravel, and sometimes it will form a mounds. While above the balls, the sand is improperly washed and mud accumulates. Okay, and when the mud formulation starts, they go on increasing in number until this entire space in the filter gets filled up with particular mud balls. Okay, please make a note on. It will also unnecessarily create a lot of problems in your cleaning of filter or backwashing of filter. Okay, so how to control this mud balls? Number one is you can these mud balls can be broken with mechanical racks, and the broken mud particles are washed off. That's number one. Number two, you can also use water stream. Okay, by using 10 diameter pipe, and you can also point at this water stream directly like on the mud balls, okay, on the top or sometimes. So that also is possible to collapse the mud balls. And you can also use sometimes this compressed air scouring during backwashing, about 4 minutes, supported with a manual surface raking, may effectively remove the mud balls as well. And the sometimes the filter gets badly clogged and damaged, then there is no other go. You have to completely clean the filter, or you have to replace with a new material. That is something is important. Okay, so please make a note on the filter bed is open, and you have a lot of problems with the open dust. It may also fall down onto a top of the filter bed and during your operation, and it will also migrate down to the filter. During the movement, it will also form a mud balls and will occupy the space, and finally it will come down to the lowest portion of your gravel layer. And during backwashing, your application of water may not be uniform. Okay, it will create one particular place with a lot of pressure, thereby it will create a lot of problems on dislocation of your bed, and sometimes it will also create a mount. And once the mud wall formation is found in the filter, then you have to clean the filter very with the different strategies. Number one, you can use mechanical racks, or you can use water stream, or you can also use compressed air scour during the backwashing. Thereby it is possible to damage the mud balls. And if this is severe damages with mud ball, then only way is to go for a simple replacement techniques. Okay, yeah. Another one is about cracking of filter, and the fine grained. In the case of say example slow sand filter, because the sand layer is only one uniform, and there could be a possibilities of lot of shrinkage cracks. Okay, please make a note on the shrinkage cracks. Obviously, all shrinkage cracks are nearby the wall junction, and with the use of with the use of filter and loss of head, and therefore the pressure of sand base goes on increasing, with the further goes on widening these cracks. Okay, so please make a note on, because of shrinkage cracks, because also is open, and if it is not uh, continuously, or there could be a formation of shrinkage cracks at the top. Okay, so what will happen? And if it is more shrinkage cracks, it will also allow all your flock as well as mud to go into a deeper of your cracks. That is something is important. Okay, so it will also affect your plant performance or filtration efficiency. So this is a famous effect in the case of slow sand filter. If it is more cracks, there could be possibilities of more passage of flocks as well as mud balls. Okay, yeah. So this is a typical sand filter will look like. Okay, either maybe in the open or sometimes inside the building. So this could be the filter during operation. Okay, so you can allow the water to pass through the filter. Okay, now you could understand better. These are inside our wash water troughs. Okay, so during now operation, you just allow the water to pass through the filter. Okay, this is during backwashing. Okay, so you just stop the influent or inlet water and allow the pressurized water to flow from bottom to top. So whatever it is being getting blocked inside the filter bed will take away, and water level also will rise up to the level of wash water troughs, and water will be collected. Through a wash water troughs and taken further for disposal or further treatment. Is it okay?
Yes, sir.
Okay, you just make a difference on during operation will look like this, and during cleaning, stop the influent and allow the water to force from bottom to up. So thereby, whatever it is getting, say example, blocked within the pores of your sand will rise with the higher velocity of water, and that muddy water can be collected through wash water troughs. Now you could understand what is wash water trough. Water will rise up to the level of wash water trough. Okay, and will be collected through this, and further will be taken into a further treatment operation. Okay, so this covers the entire the uh, the concept load with respect to filtration. Any clarifications here? Okay, so you just study some concept point of view, like whatever we have discussed so far is filtration, types of filtration methods, different types of filter, and filtration mechanism, and then filter components, and we also discussed how to calculate the head loss using Hausini equation, and the application of Hausini equations using or sense of laminar flow conditions, and also homogeneous layer of your materials or what, and some specifications with slow sand filter and also rapid sand filter. And last thing, we have discussed what are the different operational difficulties in the sand filters. One is about formation of mud balls, and second one is about cracking of filters. Okay, and how to overcome this effect also we have discussed. Okay, the one more thing is about we have to discuss some numerical problems that probably we'll discuss in the next class. Yeah. Any clarifications, Rashwant here?
No, sir.